All right, so again, for a combination, the order does not matter. The order does not matter. That's what you want to make sure you underline or put big letters there. And then there's some examples you're going to see. For a permutation, the order does matter, and that's why this comes in. Think for permutation, remember position. Position and order are the same thing. If you're in the first position in the line, you're in the first person in the line. If you're in the second position, you're in the second person. You're the second person in line. So the order matters for a permutation, whereas for a combination, the order does not matter there. So the example that you see on the board for a combination where the order doesn't matter, technically, and I know people are going to argue with me, mixing items for a cake, the order doesn't really matter. You can kind of just mix all the items together. Some instructions tell you mix the dry and wet separately and then combine them. But generally speaking, the order for these don't matter. Lotto numbers, does it matter if you get like the first number first or second?
Yeah.
No, it makes no difference actually. If you get all the numbers right, the order you got them right in doesn't matter. I could have my lotto ticket saying 5, 4, 3, 2, 1, and then the winning numbers that came out might have been 1, 5, 2, 3, 4. I still get the win for the lotto. You don't have to have them in the right order for that.
Oh, really?
Yeah.
I'm gonna stop playing lotto.
You need. We proved the other day that the odds were 1 in 3. Remember that? The odds were 1 in like 300 million though.
Yeah.
So it's still not worth playing it.
Unless you bought
Okay? Unless you bought all the tickets. But even then, with the percentage of tax that comes out, you'd still be losing. Remember we talked about that with the 640 mega million? It wouldn't even work there. But the idea for lotto tickets is the numbers really don't matter, the order. And then coins in a pocket. If you have a quarter, a nickel, and a dime in your pocket, what does that add up to?
A quarter, a nickel.
50.
40.
40. Does it matter if I have a nickel, quarter, and a dime though?
No.
Yeah.
Or a dime, a nickel, and a quarter? Does the order matter which they're in my pocket?
No, because it's the same
The idea is that it's just a combination of those three that give you 40 cents. But really, the order doesn't matter. Unless you're applying for some which does make sense actually. And the order of your money in your wallet actually does make a difference. They put it in a certain way so that when they get money out of the wallet, they're not giving a 5 instead of a 10 or so forth.
Really?
Yeah, of course.
Why do they put the different balls?
If somebody wins the lottery and then they die, do they just still give it to them?
It's their next inheritance usually. So like for example, if you win like $1 million a week for life or something like that, and well, sorry, that's a different kind of lotto. That one would stop. But if you won like $1 million or something, yeah, it's not going to just go away, your money. So you would still get the money, and then you would obviously right away you make a will that says my money is going to go to this person.
Go to their funeral.
Like the minute you win lotto, the first thing you want to do is $1 million
They die
will.
with it.
I know it sounds stupid, but it's the
I want to be
truth.
buried with them.
Just so that in case something were to happen to you, the money's not going to go away. You know? I'm sure there's conditions that they have to set up right now. It does sound like it, so I don't know the answer to that. That's my assumption for that.
And then when you die, it's in your will. I want all my money burned and none of it.
Next.
That's cool.
I still take it.
Both of these things, guys, both of them, combinations and permutations, can be with or without repetition. That's the next thing we're going to talk about. So today we're going to have 4 cases. We're going to look at combinations with repetition and without. We're going to look at permutations with repetition and without. We're going to have 4 separate cases, and each of those cases, unfortunately, has a different formula for them. What I'm going to show you, though, is 2 of these formulas you can do directly on your calculator. Okay, and there are little shortcuts to do it, and I encourage you to do that, especially on the SAT. Don't waste your time doing this stuff by hand. I'll show you when and when you cannot use the calculator to help you. So the example here is to think about the number in the lock. The number in your combination for your lock, by the way, it's called a combination lock, which we're going to prove today is actually misnamed. It's a misnomer. It should be called a permutation lock. Very good. You heard of that already? No, just assuming because it's permutation combination. Think about it. Ready? If you're dialing into your lock, does the order matter?
Yes.
It does, doesn't it?
Yeah.
Your combo is 7, 3, 24. You can't do 24, 3, 7. Right, Rolo? Can you quickly just go on Friday? We were trying to get Rolo on Thursday, right? Rolo's locker open, and we were trying to go through it, and the combination was off by something. So the order does matter in your combination. Okay, the order does matter, and as we saw it a minute ago, a permutation, with a permutation, the order matters. With a combination, the order doesn't matter. So it should actually be called a permutation lock, and not a combination lock. It's actually mislabeled. Even if they make it, the order still matters, doesn't it? Think about it. If they tell you the combination, don't you have to put it in that order? And what order matters, Julia? We are at a permutation.
But then they'd have to do that for everything. Everything has a combination and it all has an order.
Oh, I know. It's always been mislabeled. Somebody adopted the name combination lock. I don't know who, a long time ago. And since then, it's gotten all.
No, it's not like even in the bank.
I know. I agree, Jason. Absolutely. Jason's saying, like, even in the bank, when you see them open the big vault and they determine, they call what's the combination, right? When they should really say, what's the permutation?
Well,
You're not
you
gonna
get
say
it, so
that,
you
right?
get it from my
That sounds like
I'm gonna use it.
It sounds awkward. It sounds awkward.
Permutation.
Permutation, actually, because we don't have time for that. It sounds awkward.
The Robin.
Just simply because you're so accustomed to saying combination. That's the only reason it sounds weird. If you were used to saying permutation the right way, it wouldn't sound weird now. So again, for a lock, it's possible to have a repeated number. See that? You can have 4, 4, 5 as your combo for a lock. That's more than possible. But if you were looking at the people that finished a race, I know you could say people are going to tie and stuff, but let's assume it's on like Olympic race where there's not going to be people tying. Someone's going to win. You're at first, second, and third place. Okay? First, second, and third place. The order here, the order we're not going to worry about. The idea is that nothing repeats itself. Okay? Again, first place is one person. Second place is one person. Third place is one person. Okay, there's no repetition. So what we're going to do today is distinguish between the 4 cases. Again, combinations with and without repetition, permutations with and without repetition. All right. The first one we're going to start by looking at is permutations with repetition. It's extremely important that you title your notes here, that you actually write the stuff down at the top, because this is case 1. So if you want to write case 1 down above here, you can. Okay, we're going to look at 4 cases, really. 4 cases. So the first example here that we're going to look at is permutations with repetition. With repetition. And what I would like you to do is to put down in parentheses here, no calculator. Simply because the permutation button on your calculator doesn't work with repetition. It works without repetition. Okay, so in a minute when we do it without repetition, we're going to see that we can use the calculator to help us there. Yes, you will, and you can be able to look at it by looking at the actual problem. So let's look at this problem to identify why we know it's with repetition. How many different arrangements or 3-letter arrangements can the letters A, B, and C be placed into if repetition is allowed? Do you see that keywords there at the end? If repetition is allowed. Thus, this is permutations with repetition. All right, so how many letters do we have here?
3.
3, right? We have 3 choices. This is important that you label what I'm writing here, because we're going to talk about choices and slots. Choices and slots. Next, how many arrangements, or how many letters are there going to be in the arrangement? What does it say?
3.
3. So there are 3 slots. Okay, think of a slot machine, a quarter in, how many slots are there to put in there? So there are 3 slots here, and there are 3 choices. Tell me, for the first slot, how many choices do I have to choose from?
3.
I have 3 choices, because I can choose A, I can choose B, or I can choose C. Again, for the first try, I can choose any of those 3. Absolutely. Okay, I can choose A, I can choose B, or I can choose C. Now, since I can repeat it, since I can repeat any of these choices, how many choices do I have for the second try?
9.
How many? It's still 3.
Can you
Okay?
remove that?
Oh, because repetition.
Again, because repetition is allowed. Now, if repetition were not allowed, and I chose letter A, for example, how many choices would I have left? I would have 2 left. But what I'm saying is this. I choose a letter out of a hat, A, B, or C. I write it down in the first slot. I put that letter back, and I choose again. So I can repeat it. Again, imagine you had 3 tiles. Scrabble, okay? Think about Scrabble here. You have A, B, and C as tiles. You pick one of them, you place it down, or you write it down, rather. You take it and put it back in the choice box, and then you pick again. So you can repeat that letter, possibly. So you still have 3 choices here. You still have 3 choices. Finally, What is the third possibility? You still have three choices, because again, you can repeat yourself. So the third possibility, you still have three choices.
27.
Very good. 3 by 3 by 3 is simply 27. Now, what we're going to do here is we're going to generalize. We're going to call the number of choices n. And we're going to call the number of slots r. R. Okay? So again, r is the number of slots. N is the number of choices. Okay, again, r is the number of slots. N is the number of choices. So what do you notice here? You have 3 slots. Okay, you have 3 slots, and in this case, you happen to have also 3 choices. So what is 3 times 3 times 3 really, in your mind, considered to be, if you can guess that? 3 cubed. 3 cubed. That's correct. Be careful. 3 cubed. So our general formula here, we're going to look at, is going to be n to the r. For permutations, okay, for permutations with repetition. For permutations with repetition, it's always going to be n to the r. N to the r. And I should probably change this example so it's not 3 and 3. So one of them is 3 and one is 4 to distinguish. Okay, but again, it's n to the r power. That's an r as an exponent. Let me make that look better so it's clear. Okay. N. N.
You can't like put an A and then an A and then a B.
So you can. You could do AAB, you could do BCA, you could do BBB. So for each of these, you have 3 choices still, because you can repeat it. In a minute, we're going to see what happens when you can't repeat it. You have 3, 2, 1. Okay, to go down by 1. And you do a capital R, if you'd like to, but you're going to see it as lowercase in every textbook. That's why I'm just using it that way. Okay, and all the online stuff that I post, you're going to see it also as lowercase. It's up to you, John. Let's take a look at the second one. Oops, that's our statement that we just made on the board. Okay? N to the R is the possible arrangements. N is the items to choose. R is the number of slots. Number 2. If you flip a coin 10 times, how many different outcomes are possible?
No, it's same thing.
Okay?
No, it's still one
You need to think about it, guys. You take a coin, you flip it 10 times. Every single time, what is your possibility? 5. How many possibilities do you have?
2.
2. So how many choices do you have?
10.
2.
Oh,
Two.
it's 2 choices.
Tails off.
It's 2 choices, 10 slots.
So let's start.
You have a double-sided coin.
All coins are double sided.
Or 2 heads. One is not something.
Yes, this is not, we're not Two-Face here. Heads and tails. Okay? So choices, and the number of slots is simply 10. There are 10 slots. Why are there 10 slots, guys?
There's 10 times you flip the coin.
Because you're flipping it 10 times, so really here's what you're doing. Okay? That's what you're doing. And you're filling those with heads and tails. The first one could be heads or tails, right? And then I use the same coin and flip it again. Can't the second one also be heads or tails? And the third one? And the fourth one? Thus, there is repetition. You can have heads or tails every time. You could have all heads. You could have all tails. They could alternate. They could form some ambiguous pattern. It could be heads, tails, 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 heads, heads, heads. Okay? It doesn't matter what it is. But the idea is that heads can repeat or tails can repeat. Thus, there is repetition. What's my formula again?
N R.
N to the R. Remember, this is your N here, the choices, and R are the number of slots.
2, 10.
So we get 2 to the 10. Be careful again. 2 to the 10. Okay, 2 to the 10.
This is a combination.
You're right. You can put 10 on.
Why is this a permutation here, not a combination?
Because it can repeat.
Okay, let's clarify this, because
Order doesn't matter.
if I had an arrangement of this, let's say I had this as my answer. All right, let me give you a way to distinguish, guys. Make this easier.
No, because you would just flip it because then you also said
There's only one T, right?
Yeah.
Where is it?
Second.
In the second spot. Now, the T is in the second spot. If I had not made the T there, if this had been an H now, if this had now been an H and the T had been over here, isn't that a different arrangement?
Yeah.
So does the order matter?
No.
Yes.
But yes.
Again, when I switched the H and T a minute ago, it made the arrangement a new arrangement. It made it new. It made it different. Thus, the order of the letters does matter. Therefore, this is a permutation still. Again, the order of the letters does matter because as I switch these two, it's a different arrangement. Different arrangement. Okay, a different arrangement. So we have 2 to the 10th or n to the r. Anybody got this?
1,024.
Good, 1024. If you got 512, you forgot to double it again. You did n to the 9th there. You did 512. All right, let's look at the third one, and let's look at our combination lock for an example. And again, I know it's called a combination lock, but you need to make sure that you clearly cross this off and write down permutation. Well, you're going to see the word combination lock on the SAT, which is super misleading, because everybody thinks, okay, it's a combination, where in reality, it is a permutation. So I know that that sounds really annoying, but I'm just trying to give you guys a heads up.
So we don't have a permutation.
Again, why would they name it a combination? I don't know.
I think it's just so they can have fun when they're grading these tests.
They're getting paid. They don't.
Again, it's been called the combination lock forever, so the SAT is going to call it that, but they mean a permutation here. Again, they mean a permutation, because the order does matter. Okay? Try this on your own. Think about how many choices you have on your lock. You should know that. And how many slots there are. How many different ones you can stop.
Hey.
49.
No, it starts at 0. I know that.
49.
No, because it starts at 0. No, I know that one.
You said 49.
Is it 0 to 30? That's the one from
I
my
thought it was straight, right?
Is it 0 to 30?
It's 40. What? What's that?
40.
Last year the scores, there were some things that were in the
30s.
I don't know. Somebody.
So it'd be 39.
40.
I don't know about this. You count as zero. You use zero.
So would you?
Who has a lock on them? I don't know by heart.
A lot of other schools, no students.
So you were born on your first birthday? That's the day you were born? No, you were born on your birthday. So then you start at zero.
All right.
And you go to 1.
I
So,
don't get it. I don't.
first of all, how many spots are there on your lock?
So 40.
Is it 40?
Can I go check?
It's 40.
Can we go?
Does anybody have a number in their lock that's in the 30s?
I have
47.
39.
So then it's got to be 40. Does anyone have a 40 in their lock?
Wait, how is it?
No, it's 0 through 39, right?
Huh?
Which is 40 choices. But keep that in mind, guys.
See? You just proved my point.
0 through 39 is 40 choices, really.
Good job, Derek. Said it
Okay.
Wait, what?
I didn't mean anything. Yes, I did.
Whoa, what?
Oh.
The whole thing.
Got your flag.
Okay, you can choose any number between 0 and 39. That's 40 choices, actually. Because you have to include 0 as a choice. If you just counted 1 through 39, that's 39 choices. But 0 is actually a choice on it. Next, how many slots are there?
40. No, wait, no.
1.
3.
You choose three
Guys,
numbers for your lock.
slots are the amounts of numbers you actually have in the combination. How many do you have?
3.
3. Okay? And use your formula. What's our formula? For some reason, when I made these notes, I decided that you had 60 values on your lock. I don't know what lock I was looking at. So if you look at the notes, they're going to be a little different.
It was a Delta lock.
I don't know. How'd that happen? Okay.
What's the delta look?
I don't know. Just made it up.
What do you get for this one?
64,000.
Good. Because 4 to the third is 64. So it's going to be 64,000.
That's a lot of options.
Okay? So try to break into someone's lock. Bro, did it work last week? We tried to break into your locker? Not until we remember the combination, right?
No,
yeah. It's very tough to just sit there and guess, okay?
Well, then have those those movies.
How do they listen to it?
Hey,
Yeah, how
put
do
in
you
his
do
lock.
that?
Oh,
Wait, is it because they're trying to hear where like the locks clicks
Yeah.
and everything like that? So they know.
People that like know how to open locks and stuff, that's a whole other like skill set. I mean, they're like listening to the pin to change its position and stuff that's holding the lock in. And a lot of the stuff you see in movies, they're electronic now, the codes. So they have a computer program that runs like every variation. Like, if this was electronic, 64,000 is nothing. That's a small number, tiny number. Think about it this way, guys. Social Security number. Social Security number, you have 10 choices and you have like how many slots? You have 8 slots for your Social Security number. Okay, 8 slots and there's 10 possible number choices. Okay, so it's a very, very large number, whereas this is a very small number.
Yeah.
64,000 is not a lot. A computer program can run through that in like maybe a minute or so. And get you
That's
that.
nice.
That's
Five, 27, 39.
But guys, locks are not electronic. Thus, computer programs can help.
If you look for something that's computer program, you don't generate some number. Like you generate some number.
It's
not.
I counted real quick. 9 in your Social Security. Anyway, this is our answer here. All right, next. Now we're going to look at permutation without. Listen, please. Listen. Without repetition here. Without. Now, this problem you can use your calculator on. Here's how I remember it. Okay, if you want to make it very simple. When it says without, think with for calculator. Again, this problem says without repetition, right? So it's with a calculator. Think the opposite. When it's with repetition, you do it without a calculator. When it's without repetition, you can do the problem with a calculator. With and without mix each other up for repetition and calculator. That's how I remember. Because if you try to use your calculator for permutations on the last problems, you're going to get an incorrect answer. I'm telling you right now. Okay? Again, you're getting an incorrect answer. So, what we're going to do first, before we use a calculator, is derive or show where the formula comes from and why the calculator will help us. We have 5 different billiard balls, pool balls. We've heard this term before? Okay, like the cue ball, the 8 ball, the 7 ball, the different types, stripes and solids. So we have 5 of them, and they are different. And we're going to order them. So, we're going to order them. So let's say I've got a 7, a 6, a 5, a 2, and an 8. Those are the 5 billiards. Okay, again, I know they're different colors. Now, for the first possibility, or the first slot, how many choices do I have?
5.
I've got 5 choices. 5 choices for the first slot. Now, once I choose one, though, what happens to it?
You only have 4.
You only have 4 left. Because now we are ordering them. And in order to put something in order, you have to actually have one of these choices here. So let's say we choose the 7 to go here. Okay, there are 5 choices there. Not the number 5, but 5 choices. Then we said again there would be 4 choices. Because now let's say the 2 gets chosen, and the 2 goes over there. Now how many choices are left?
3.
And then?
2.
And then?
1.
What is this called? When you multiply down the order from the top number all the way down to 1. Okay, so maybe we haven't learned this yet. This is called factorial. Have you heard that before? Okay, so let's define this now. Let's define this. N with an exclamation means the product of n and all whole numbers less than n. Whole numbers are not negatives. Whole numbers are not negatives, remember. Integers considered negatives. Whole numbers are not negatives. So n factorial, again, n factorial is the product of n and all the whole numbers below it. So for example here, 5 and then 4, 3, 2, 1. If it was 10, it would be 9, 8, 7, 6, 5, 4, 3, 2, 1.
So it would be on 10.
Yes, that would have been 10 exclamation, absolutely.
So it's the number that you start with?
Correct, that's all it is. That's it. Again, whatever number you start with, every number less than that is going to be in the product. So if you had 20 factorial, 20, 19, 18, 17, all the way down to 1, you have to multiply all those numbers. So what do you get when you multiply 5, 4, 3, 2, 1? Multiply. 120. Very good. You can use your head for a lot of this stuff, guys. You don't have to do this. You do not have to do this kind of problem on a calculator. Okay, you don't have to do this problem in the calculator. Now, before we move on to the next example, I want to prove to you that the calculator does help, though. What was n in this case? How many choices did I have?
5.
I had 5 choices. And how many slots did I have to fill?
5.
I also had 5. So, let's bring up our calculator and show where this is now. So remember, n and r happen to be 5, and we're doing it is fine. And we're doing permutation. Again, n and r are both 5, and we're doing permutation. Okay, and we can use our calculator because it's without repetition. So we can use it with a calculator. Alright, so if we want to show that it's 120, okay, we want to show that it's 120, we want to find a button, God bless you, that has a permutation or a combination on it. So everybody hit math, please. Okay, hit this button right here that says math, right below alpha. Go over until you can find it. Search through your categories. You'll find it. Go to the right and left, and soon you're going to see an NPR and CR in there. So if I go to the right, there's nothing there, nothing there. See these NPRs and NCRs? What's the category title, guys?
Probability.
Probability. Very good. And what are we studying? Probability. Take a look. Isn't that your factorial?
Yeah.
This is your NPR and CR. So you can do a permutation on the calculator by pressing the number 2 right now. Pressing the number 2 for a permutation, because that's what we're doing. So press the number 2. Now, before I press the number 2, though, here's what I need to do. The command is always, you type in N, then you press that, and then you type in R. See how it's NPR? You need to put a number here beforehand. What was the value of N? Was 5, right? So we have to put a 5 there. Then on the other side, put the R value. So this is the N value. So you start by typing N, whatever N is. Then you go to your math button. You go over to probability. You press the NPR button. It'll show up this on the screen. Then you type in the R value. Okay? And then just hit enter.
Okay, so I understand that. When you have to get that.
You remember we got 120 as our answer? Louise said 120 there. This is the N value over here. This is the R value over here.
So you can do the same when we get to the combinations. That's all the NCR will do.
For combinations you can, but again, combinations without repetition works with a calculator. Same pattern applies. Again, the calculator is only going to help you when it's without repetition. Without repetition. Okay? So keep that in mind. With a calculator means without repetition. So we did this one for 5P5. Okay? If you were to write this, just so you can see this on your test or something, it would look like this. 5P5. NPR. Okay, again, this comes from the fact that it's NPR. Okay, NPR, not NPH, NPR. Okay, yes. Cosine? Absolutely.
Oh,
No, it's not on your SAT. All that's on, guys, all that's on your SAT is basic SOHCAHTOA, like right triangle trick. There's no stuff with like, there's no sine waves and cosine waves, and you're going to learn about amplitude and frequency. All that's on the SAT, is just sine equals opposite of hypotenuse. Cosine equals SOHCAHTOA, adjacent hypotenuse. Tangent equals opposite of adjacent. Being able to find a side if you're given other spots. The stuff we did last year in geometry.
Can we go over that, please?
On Thursday, we're going to have just a little bit of time. If you want to do it then, that's fine with me. Sure. Yep. Again, guys, if you looked at the geometry video online, you would have seen some of that Mr. Malachek recorded before. All right. 5, 4, 3, 2, 1 is 5 factorial. Let's do our next one now. Oops. Let's do our next one now. Now, there are 5 available pool balls here. How many different orders can 3 of them be placed in? Hey. How many different orders can 3 of them be placed in?
This is combination, right?
Once I choose one of them, Juliet, and put it down here, right? Like let's say the 5 available pool balls this time are 7, 4, 2, 9, and 12. Those are my 5 choices. Once I place one of them there, I can no longer use it again, so it's without repetition. And if I get 7, 4, 2 versus 2, 4, 7, are those different orders?
Yeah.
So does order matter?
Yeah.
You're answering your question and then you're answering it wrong afterward. Let's go through this again. I've got 3 slots, right?
Yeah.
If I place a 7 here, a 2, and a 9, that is different than a 2, a 7, and a 9. Because it says how many different orders. These are different orders, aren't they? So order matters, therefore we're still on permutation. Again, permutation, order matters. Permutation, think position. Okay, again, so this is a permutation, and again, it's without repetition.
No.
Is there a 12?
Yes.
Yes, that's a 12. A 12 pool ball, sorry. So again, in this kind of a problem, we've got 3 slots, and how many choices? 5 choices. So n equals 5, and r is equal to 3. Okay, again, 5 choices, but only 3 slots this time. So, how many choices for the first one are here?
5.
Once I pick one of these, I cross it off, right? Because I'm not repeating. The order matters. And I don't have the same pool ball multiple times. How many are left? And then? What's 5 by 4 by 3?
60.
60. 60. So, is this bigger or smaller than my last answer? Smaller, right? The number went down. It was 120 last time. Okay, last time, all we had to do was take the number of choices and put an exclamation next to it, right? It was 5 factorial in the end last time. That's what we had last time. But now this number got smaller. This value got smaller. So what we can generalize or say in general here is that, and you don't have to memorize this formula because this one you can always do on a calculator. Okay? We have to remember that whatever n is, we do that factorial over n minus r factorial. And we'll prove that for the last one. Okay, but to write this down for a quick second, n and r are still the same thing. N is still the number of choices, r is still the number of slots to fill. N is still the number of choices, r is still the amount of slots we need to fill here. So in the last problem, we had n was 5, there were 5 choices, and there were 3 slots. That was the one we just did a minute ago. Again, guys, you don't have to rewrite this definition down in this definition. It's the same thing we said in the beginning. It's always going to be the same. So if n was 5 and r was 3, okay, the possible arrangements is going to equal n factorial over n minus r factorial. If I were to plug into the formula here, just directly plug it in. So the top becomes 5, 4, 3, 2, 1. That's what the top is really, right? What's the bottom though?
5, 4, 3. No.
It's just 2 factorial, as Trayvon said, which is 2, 1. So I got 5, 4, 3, 2, 1 over 2, 1. What do you know about these that are going to cancel here? Because they're all factors, right? So we can cancel. What are you left with? Isn't that what we had? If you look back? Look back at the example. We said there were 5 choices, then there were 4 choices, then there were 3 choices. When multiplied, we got 60. That's where it comes from. So this is your general formula you can always use. But you do not have to memorize because you can use NPR on the calculator here. So I'm encouraging you guys not to memorize this because there's 4 formulas total. The first one we did was n to the r. Then this is the second formula. We're going to have 2 more formulas for combination. If you're going to have to memorize, just only memorize 2 of them. Use the calculator for the other 2. So go ahead in your calculator, please. Try this yourself. Type in 5, press the NPR button, then type in a 3. So go to your home screen, press 5 first, then go over to your math, go over to probability by pressing left, then go down to NPR, hit enter, and then the value of R was 3, there were 3 slots, we got 60 as our answer. Again, when the problem is without repetition, it is with a calculator. When the problem is without repetition, it is really when we can use a calculator. Okay? So, what we're going to do is this. We're going to stop here before we get to combinations. Because combinations, the formulas get a lot more complex. Okay? Permutations, what was the key parts here? Who can summarize, give me some key points from today? What's one thing about permutations that was important? Eric.
You have to know, you have to know how many slots you can.
Good. How many slots you can fill?
The order matters.
The order matters. And the amount of choices you have. One more thing, actually, sorry, one more thing. With or without repetition. So the 4 things that we have to remember every time we do a problem like this. Again, the order, okay, if it matters, and we can make a tree diagram. If it matters, then we have a permutation. If it doesn't matter, then we're going to see tomorrow that we have a combination. That's the first thing we have to think about. Good. Next, the number of choices. And we call that, what variable is that? N. Good, N. Big number, right? Number of choices. Although number of slots can be misleading now. Number of slots was considered to be R. Number of slots was considered to be R. And then finally, with or without repetition was the last thing to write down. So with repetition and without repetition. With repetition, we can automatically go to our calculator. We can automatically use our formula when it's with repetition. When it's without repetition, we can simply use our calculator. Okay, that's REP for repetition. So we have 2 choices at the bottom also. Again, when it's with repetition, we can go to our formula there. The first formula that we used for permutation was N to the R. Okay, that was the first formula there. But when it's without repetition, we can go to our calculator. When you see tomorrow the combination formulas, you're going to see why it's important that we're using our calculator also. Because right now it doesn't seem that important. You can probably memorize those 2 formulas pretty easily. And it's good to know them. But again, when it's without repetition, like the last example, you do not have to memorize n factorial over quantity n minus r factorial. There's no need to memorize that. Just use your calculator. Okay? Questions at all? No? Okay? I'm going to do something I often do not do. I'm going to give you tonight off for homework. Okay? Here's the reason why. And I always encourage homework every night. What I'd like you to really focus on is just editing your portfolio. I'm not going to have it due until next week to give you guys a weekend also. Okay, instead of the end of this week, because I just gave them back today. I wanted them back last week, but some of you got them back today. So they're not going to be due until next week. All right, so Monday you guys do not work. So Monday is the day it's going to be due. Your final draft. Remember, your rough draft was only 20 points. Your final draft is 30 points. These are test points, guys. And some of you drastically need these test points. So don't just blow this off even if you didn't do the rough draft. You saw the rubric I put online, okay? So you can see where you're missing stuff. Jason, I'm getting yours back to you after this, okay? Again, if you didn't hand in the rough draft, it does not mean just ignore the final draft. It's still worth 60% of the grade, really. 40% of the grade was the rough draft. This is really now worth 60% of the grade. Okay, it's a lot more. Also, when you're doing your homework tomorrow night for this, it's very important that you're able to distinguish. You're able to distinguish between combination and permutation. So we're going to wait until we've learned both of those. Okay? Again, if you need to make up quizzes already for this stuff, you might want to be handing in your homeworks to me, or at least showing me those homeworks. Okay? So I know that you're doing them so you can make up a quiz whenever you need to.